Hi students, this is Alex here. In this video, we are going to expand the given function f of x e power minus x as a Fourier series in the interval minus 1 comma 1. Let's check whether the given function is even function or odd function. So I have to take f of minus x. It means every x is replaced as minus x, and ultimately we are getting e power x, which is not equal to f of x. It means f of x is neither even nor odd. F of x is neither even function nor odd function. So we have to find a naught, an, bn as usual. A naught by formula, it is 1 by L integral minus L to L f of x dx. And here L is 1, so 1 by 1 integral minus 1 to 1 f of x is e power minus x dx. Integration of e power minus x is e power minus x by minus 1, and we have a limit from minus 1 to 1. So e power, when I put the upper limit minus 1 by minus 1, then minus of e power, when I put the lower limit, it becomes 1 by minus 1. So finally these two gets cancelled and this is plus. So first term is minus e power minus 1, second term is e power 1. So this can be rewritten as e minus e power minus 1, and we have a hyperbolic function formulas, that is e power ax minus e power minus ax by 2 will become sin h ax. But in this case, this ax is 1 here. So this is 2 sin h, ax is 1, so 2 sin h of 1. So we got a naught equal to 2 sin h of 1. We can keep either this or our original term e power 1 minus e power minus 1. So anything is fine here. So we got a naught. In the same way, we are going to find an. So an by formula, an equal to 1 by L integral minus L to L f of x into cos n pi x by L. Here the value of L is 1. So it is 1 by 1 integral minus 1 to 1, and f of x is e power minus x into, and this becomes cos n pi x alone because L is 1, and we have dx also. Now when we want to integrate this, we have a basic integration formula. We're going to apply that formula directly. Integration of e power ax into cos bx equal to e power ax by a square plus b square into a cos bx plus b sin bx. And here in place of a we have minus 1, and in place of b we have n pi. So when I apply this, e power minus x by minus 1 whole square plus n pi whole square. This is a square plus b square. Then a cos bx n pi x plus b sin bx. So I replace b as n pi. Then this entire thing is enclosed in a bracket, and we have to apply the limit minus 1 to 1. When I apply the upper limit, we get e power 1 by 1 square plus n square pi square, and here this becomes minus cos n pi plus n pi into sin n pi. Anyway, sin n pi is 0, so that we can make it in the next step. So we apply the upper limit minus, when I put the lower limit, this is e power x. Actually, e power minus of minus 1, e power plus 1, and but this is e power minus 1. When I put upper limit 1, it is e power minus 1. So here it is e power 1 by 1 square plus n square pi square. When I put minus, still it is cos n pi only, because inside cos theta, if I have negative, it can be ignored. And when I put here, it is sine of n pi into minus 1, but anyway it is 0. So I directly write 0 here. So finally we can take 1 by n square plus n square pi square common. After that, we have e power minus 1 into minus cos n pi, and anyway this part is 0, and this is minus of minus, it will become plus. So plus e cos n pi, and cos n pi can be taken outside, which is minus 1 whole power n by 1 plus n square pi square into, I write this as first and this as the next. So we can either keep like this, or we can also replace with 2 sin h of 1. So either this or an is 2 sin h of 1. Along with that, we have minus 1 whole power n by 1 plus n square pi square. So thus we got an. We can use either this or the second part. In the same way, I have to get bn. Now bn, the formula is bn equal to 1 by L integral minus L to L into f of x into sin n pi x by L dx, and L is 1, so 1 by 1 minus 1 to 1, f of x is e power minus x, and here L is 1, so sin n pi x alone. Again we are going to apply the basic integration formula, integral e power ax into sin bx dx. This formula is e power ax by a square plus b square. Here a sin bx minus b cos bx, and we have plus c, but here we have a limit, we don't apply that plus c here. So now using this formula, it is e power minus x by 1 square plus n square pi square, because a is minus 1, b is n pi, then a sin bx n pi x minus b n pi into cos n pi x, and we have a limit from minus 1 to 1. Now using the upper limit, e power minus 1 by 1 square plus n square pi square, then here when I put 1 sin n pi, which is 0, so no need to write, and here n pi into cos n pi is minus 1 whole power n. Now using the lower limit, this is e power 1 by 1 square plus n square pi square, and again this becomes 0, and this becomes same, minus n pi into minus 1 whole power n. So we finished applying upper limit and lower limit. Now we can write e power minus 1 by 1 square plus n square pi square, and this can be written as minus n pi into minus 1 whole power n, and here this becomes plus. So plus e by 1 square plus n square pi square, we have n pi into minus 1 whole power n. So finally we can take n pi, then minus 1 whole power n common, and denominator 1 plus n square pi square also common. After that, let's write the positive term first, then minus, there's a negative sign, so e power minus 1. We can leave like this as bn, or it can also be written as 2 sin h of 1. So n pi minus 1 whole power n by 1 plus n square pi square, and this is sin h of 1 2 times. So we got an and bn. Then we can substitute this in the Fourier series expansion formula, that is f of x equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by L, L is 1, plus summation n is equal to 1 to infinity bn sin n pi x by L, but n is 1, L is 1, so we stop here. A0 by 2, A0 we we can either take e power 1 minus e power minus 1. So I write it here, e power 1 minus e power minus 1 by 2 plus summation n is equal to 1 to infinity an. So an also we can take minus 1 whole power n by 1 plus minus 1 whole power n by 1 plus n square pi square into e minus e power minus 1 into cos n pi x plus summation n is equal to 1 to infinity bn, that is n pi. So here it is n pi minus 1 whole power n by 1 plus n square pi square into again e minus e power minus 1 into sin n pi x. So either we can leave like this as our f of x, or e minus e power minus 1 by 2 can be replaced as sin 2 sin h of 1. So either this can be given as the answer. Still some of the terms can be taken out common. E minus e power minus 1 we can take out as common. Now I write that outside, then I replace with sin h 2 times. So e minus e power minus 1 by 2, if I take common totally, here we have by 2. So 1 by 2 is remaining. Then after taking this common, we have summation n is equal to 1 to infinity. We have only minus 1 whole power n by 1 plus n square pi square and cos n pi x plus summation n is equal to 1 to infinity. Here if we want we can take pi common, or else we can keep it inside also. Pi into minus 1 whole power n by, actually there is n pi. So n pi into minus 1 whole power n by 1 plus n square pi square into sin n pi x, because we have taken only e minus e power minus 1 by 2 alone common. So this is our f of x. Actually we are not taking this by 2 common. We are taking only e minus e power minus 1 alone common. Because first term there was by 2, so by mistake I wrote by 2. We are taking only e minus e power minus 1, and rest of the terms we have written as it is. So if you want we can replace e minus e power minus 1 as 2 sin h of 1, and rest of the terms are as it is. So 1 by 2 plus summation n equal to 1 to infinity minus 1 whole power n by 1 plus n square pi square cos n pi x plus summation n is equal to 1 to infinity n pi minus 1 whole power n by 1 plus n square pi square into sin n pi x. So we got the Fourier series expansion for the given function.